go through a few examples in this packet together. So you should have received a packet from the sub, and you have a quiz on Monday on 8.1, 8.2, and 8.4. So you should have received a packet that covers those sections, and I'm going to go through some of it with you. You do have notes on all of this, so if you want to get those out, that might be helpful, but I'm just going to kind of explain maybe a few concepts on each page. So we've done a lot of these together. I'm going to look at number 4 with you. This is what we did on Monday. So the vertex, we're just going to list the vertex. The vertex of this function is right here, and the coordinates are -2, -5. So we're just listing x and y because the vertex is a location. It's a minimum because it's on the bottom of the parabola. The axis of symmetry, remember if I were to graph it, it's a dashed line going through the vertex. So it's an equation of a line. You have to have x equals to indicate that it's a line, and then -2. Remember, it's always going to be the same as the x value of the vertex every single time. So this will be the same as this every time. The roots, so the roots are the x-intercepts. I'm going to highlight them like in blue on the graph. I see x-intercepts at -4 and at 0. You can just put commas between them. The domain is always all real numbers. The range of a parabola is not always all real numbers. It's either going to be y is greater than or y is less than or equal to something. So this one's greater than or equal to because the arrows are on the top, which means it extends up forever. The bottom of the parabola is at -5, so we're going to say y is greater than or equal to -5. It's increasing and decreasing, so it's decreasing on the left side is going down, so I'm just going to write decreasing over here, and then the right side is increasing, so this part is increasing. So when you're describing them, you describe them in terms of x. So the left side of it is decreasing, so it switches at the vertex. So remember, you can kind of just always set this, you can always kind of set it up like this first, and that's the x value of the vertex. The left side is decreasing, so that'd be x is less than is the left side. The right side is increasing, so that's x is greater than. This whole page is that same thing. So again, you have more examples in your notes. The next page of this, we are graphing, we're describing the changes. So we've kind of done a lot of this. I'm just going to pick one of them to go through with you, and I'm probably going to pick one that's one of the more complicated ones. So let's do number 9 together. So remember, when I do these, I always describe the changes first. So just using those rules that we've been talking about all week. This 1/2 is the a value. We talked about how that impacts the wideness or narrowness. When you're describing it, though, you're going to call it a vertical compression or a vertical shrink, and it's times 1/2. So remember, that actually creates a wider looking parabola because it's like you're pushing it vertically, which makes it wider. And then this number out here is going to shift it. It's a vertical translation is what we call it. You can just write down 3 units. Fill out your table like we've been doing all week. So I'm going to show plugging in -2, 1/2, -2 squared. Obviously, there's not a lot of room here. When you're evaluating this, you want to square it first, order of operations. -2 squared is 4. 4 times 1/2 is 2. 2 minus 3 is -1. This is also going to be -1 when you plug in +2. When you plug in 0, remember, you're just going to get whatever value is here on this type. So this is -3. Plug in -1 or +1. Remember, you can use the calculator on this. -1 squared is +1. 1/2 times 1 is 1/2. 1/2 minus 3 is going to be -2.5. Plot your points. So -2, -1 is right here. -1, -2.5 is right here. 0, -3 is here. 1, -2.5, 2, -1. So it's kind of a wide parabola, and the vertex is shifted down 3 from the origin. Okay, so that's that page. This whole widest to narrowest thing has been on your homework. I did talk about it briefly, but just a reminder, whether it's negative or positive here really doesn't matter in terms of the wideness versus narrowest. The widest is going to be the one that has like the smallest number in front. So we're looking for 1/2 would be the smallest number in front. Remember, negative or positive doesn't matter. So this one's going to be wide because it's going to be a vertical compression, which is going to push it down. So the first one you're going to write is y equals 1/2 x squared. And then you're just going to continue ordering them. So the next one would be 2/3, etc. And if it says narrowest to widest, obviously just do that backwards. So you can check that on the answer key when you're done, and you can check everything else too. So now we're getting into vertex form, which is what we did yesterday. So there's some of those here. Again, I'm not going to do all these, but I'll just kind of walk you through a couple of them. So in this top section, I'm going to pick one that maybe looks a little bit more like complicated. Like, let's talk about this one, for example. So that 3 is not going to impact the vertex. The A value out front, so this A value, impacts how wide or narrow the parabola is. It's a vertical stretch or compression, but it doesn't change where the vertex is. So this -7, remember, the vertex is actually going to be the opposite of that for the x value because it actually moves it left. So it's going to be -7. And then the y value of the vertex is always equal to whatever's out here. You don't take the opposite of it. So it's -7, -1. On something like the one underneath it, similar to what I said on the last one, this negative out front, that just makes the parabola open upside down. It doesn't change where the vertex is. This +5 is going to shift the graph. It's going to be a translation left 5, but it's going to make the vertex -5 for the x value. There's no number out here, so there's an invisible 0. So the y value of the vertex is 0. So that's your answer on that one. Here, we have kind of the same type of question, but just expecting us to do a little bit more. So I'm just going to pick one of these to go through with you, and then I think we will be done. So this one, this -2 in front is the A value, doesn't change the vertex. The vertex is going to be -1 because it's going to be the opposite of that number. And then +3, it's equal to that one for the y value. Axis of symmetry always goes through the vertex, so it's x equals -1. The domain is all real numbers. The range, we can kind of figure out the range from looking at the equation possibly, but it's probably a little bit easier to do it after we graph it. So I'm going to hold on for that. I'm going to write out the transformations now, and then the rest of the questions, like these two, I'll answer after we have the graph. So for the transformations, there's a lot going on here. I count 1, 2, 3, 4 transformations. So this negative in front is going to be that reflection. It's called the reflection in the x-axis or reflection across the x-axis. I'm just going to write x-axis in parentheses. So that's one of the transformations. Another one is that the 2 out front, because 2 is bigger than 1, is a vertical stretch by a factor of 2. Then this +1, we talked about it moving the graph left 1 unit. So there's a translation, left 1 unit. Translation just means like sliding the graph to the left 1. And then the last thing is that +3 outside. A number outside moves it up or down, and that one is up. Remember that the number inside kind of does backwards of what you would think. It actually moves it to the left 1, this number inside the parentheses. And then the number outside does exactly what you would think, it moves it up. So now we're going to get into the actual graph. So to do the actual graph, I'm going to fill out the table. I'm going to put the vertex in the middle. So I'm going to put -1, +3 in the middle. And then from there, I'm just going to subtract this way. And then I'm going to add this way. So they're going to get smaller above it and then bigger below it. And then I'm going to actually plug the values in. So when I plug in -3, I'm going to do it over here. Remember, you can use your calculator for this. -3 + 1 squared + 3. Type that whole thing in your calculator like I showed you, or do it in your head. This is -2. -2 squared is +4. -2 times 4 is -8, plus 3 is -5. Plug in -2. You get -1. -1 squared is +1. -2 times 1 is -2, plus 3 is 1. Plug in 0. You're going to get -2. 0 plus 1 squared plus 3. 0 plus 1 is 1. 1 squared is 1. -2 times 1 is -2. Plus 3 is 1. Remember, we already knew that because these are going to match up. I'm just kind of showing you. We did talk about this yesterday. Then plug in 1, -2. 1 plus 1 squared plus 3. 1 plus 1 is 2. 2 squared is 4. -2 times 4 is -8. Plus 3 is -5. As suspected, it matches up with this one. So plot your points. So -3, -5. -3, 1, 2, 3, 4, 5. -2, 1 is here. -1, 3, 1, 2, 3 is here. 0, 1 is here. 1, -5 is down here. Then we'll answer those last couple questions. So the range is going to be y is less than or equal to. The arrows are going down. The y value of the vertex is 3. The vertex is a maximum because it's on the top. So that's how you do those. The word problems, we already did those. There was a problem very similar to this in your 8-2 notes if you want to look at it. And then these ones are just matching. I would think about where the vertex should be. So this one, for example, part D, there's a +0 here. So your vertex should be the opposite of this number. So it should be +2, 0. So we'll find one that has a vertex at 2, 0. Looks like it's got to be this one. So D must be this one. It says to explain it. I'm just going to say the vertex of D should be 2, 0. So that's how you're going to approach those ones. Okay, I think that's it. So work on this for the rest of class. I think you should have enough time to finish it. You can check your answers. There is an answer key in the front of the room. And then at home this weekend, there's one on Google Classroom as well. On Monday, the quiz is a little bit longer than I thought it would be. So we'll have a little bit of time to go over things. And I'm going to collect your warm-up sheet on Monday, and then we'll take the quiz. Next Tuesday, we will move on in this unit. So I will see you on Monday. Have a good weekend. Bye.